Welcome to today's mathematics class. In today's class, we are going to provide solution to this question on integration. But before we do that, if today is your first time of seeing me on this page, help us to share this post to a greater number of students on this platform. And also consider liking and follow me on this page. I will be providing you with content that you can't afford to miss. Okay. Now, we have integrate sec to the power of 6x dx. Now, there is no way we can just solve this. There is no standard way we can solve this. So what we need to do is to use substitution. Yes, we can use substitution here. It may work, it may not work. But before we do that, I want us to express this here. If we decide to say let u equal to sec x, so it will take us to a long process. But now let us break this power down so that we can have an identity for one of the factors. We are going to break this one. For us to have power up to 6, it means here is the base. For example, assuming we let u equal to sec x, so which means we are going to have u raised to power 6. Now, I can break this 6 now to have the same base to be u raised to power 2 times u raised to power 2 times u raised to power 2. So here, at the end of the day, if you apply the law of indices to this right-hand side, we are going to have what we have on the left cell here. So nothing has changed. So we can come here, use this kind of expression here to replace this one here so that we can have an identity for one of them. So what we are going to do is it can give us, so this one here can say, it can also be expressed as u raised to power 4 times u raised to power 2. Or this u raised to power 4 here can also be expressed as u raised to power 2, then having another power inside according to indices, then times u raised to power 2. So this is how I am going to express here what I have here in form of what? In terms of what? Sec x. In terms of sec x, to give us the integral of sec square x. That is this one here. Then we have square, then another sec square x, then we have dx. Good. So what we have here is still the same thing as what we have here. Nothing has changed. If you follow this illustration I gave here. Now, we are going to look for a way we can replace this one inside here. There is this trigonometric identity where we have tan square x plus 1 equal to sec square x. So I want you to go to your trigonometric identity. There is one identity that has this. So which means we can replace sec square x with this. So in any of this, so we are going to use this one. Let us replace it with this one so that we say let's, okay, before that, we have now, it's now become tan square x plus this one plus 1, then all squared because of this square here. We have sec square x dx. Good. We are going. So from here, we can use substitution now. We can use substitution here. We can say let u equal to tan x. Just tan x, not tan square x here. So we say let u equal to tan x. Now we are going to differentiate with respect to x. And there is a standard derivative for tan x. What is that standard derivative? Say the u dx becomes equal to sec square x. So when you differentiate with respect to x of tan x, it will give us sec square x. So here we want to make the u the solid of formula. Just cross multiply so that we have du, so that we can have du equal to what? Sec square x dx. Now remember, this integral now will now become, we have the integral, we have tan x to be what? U. Tan x is our u, so which means we're going to have u squared plus 1. And there is another square here. Then sec square x dx. Look at it here. Sec square x dx is equal to du. So which means we put du there. This becomes our du. Now, we are having this here. We have to open the brackets now. This now give us, we have to expand u square plus 1, then u square plus 1, then du. Now, let us go. What you need to do now is to open the bracket. This multiply this gives us u raised to power 4. Then this one times this one gives us what? U square. Then this one times another u square again to give us what? U square. That means we have 2u squared. Then 1 times 1 to give us what? Plus 1. So we have du. Now we can now integrate. Let us integrate according to our standard integral. We are going to add the power here, become u raised to power 4 plus 1 all over 4 plus 1, then plus 2u raised to power 2 plus 1, then all over 2 plus 1, then plus this one will give us what? U. So what we are going to do now becomes u raised to power 5 all over 5 plus 2u raised to power 3 all over 3 plus u. Remember, plus what? Your constant. Plus constant. So, of course, you can remember that our u here is not given to us in the question. So our u is this one, tan x. So we are going to substitute this tan x for u in this last expression here. So your final answer now becomes, we have 1 over 5. 1 over 5, we have tan x raised to power 5. Then plus 2 over 3, we have tan x raised to power 3. Then plus tan x plus c. So 1 over 5 tan x to the power of 5 plus 3, okay, 2 over 3 tan cube of what? X plus tan x plus what? C. This is the final answer. I hope you find this video very interesting. If that is true, help us to share so that other students can benefit from this video. Bye.